Have you ever wondered why time seems to fly when you're having fun but drags when you're bored? It's a common question, isn't it? We've all looked at the clock, surprised that hours have passed in what felt like minutes. Or, on the flip side, we've counted every second during an excruciatingly dull event. This relativity of time perception isn't just a figment of our imagination, it actually has roots in science. Consider a day at the amusement park, filled with thrilling rides and laughter. Time seems to rush by, right? But let's compare that to a day at the office, where the ticking of the clock seems to slow to a crawl. This phenomenon is what scientists refer to as time dilation. It's a concept that suggests time doesn't pass at a constant rate in different situations. It's intriguing, isn't it? So, does time really change speed, or is it all just in our minds? Let's delve deeper to find out. Picture yourself standing on a platform watching a train race by. Now, this isn't just any ordinary train. This train represents a moving object, and you standing on the platform are the observer. This is an analogy we will use to illustrate the concept of time dilation. Let's add another layer to this analogy. Imagine there's a clock on the train and another one with you on the platform. Both these clocks are perfectly synchronized. As the train begins to move, you notice something strange. The clock on the train appears to be ticking slower than your clock. Weird, right? But why does this happen? This is where the magic of time dilation comes into play. You see, according to Albert Einstein's theory of relativity, the speed of light is the same for all observers, regardless of their state of motion. So if you were to shine a light from the floor to the ceiling of the moving train, the light would appear to take a diagonal path to an observer on the platform, due to the train's motion. This path is longer than the straight up and down path the light would take in a stationary train. However, since the speed of light is always constant, the only way to reconcile the longer path and the constant speed is if time itself slows down on the moving train. This is time dilation. To the observer on the platform, it seems as if time on the train is moving more slowly. But for the passengers on the train, everything seems normal because they are moving with the train. This might sound like something straight out of a science fiction novel, but it is a very real consequence of the theory of relativity. It might be hard to wrap your head around it, but this is the universe we live in. A universe where time is not as fixed and unchanging as we might believe. So, according to this analogy, time can actually slow down. But how does this happen? To understand time dilation, we need to delve into the world of physics. Let's rewind to the early 20th century when a man named Albert Einstein introduced us to his theory of relativity. This theory has two parts: special relativity and general relativity. Special relativity tells us that space and time are intertwined into a four-dimensional fabric known as space-time. Imagine a trampoline, where the fabric represents space-time. When something heavy, say a bowling ball, is placed on the trampoline, it dips, creating a curvature. This is how gravity works, according to Einstein's theory. Now let's introduce time dilation. Time dilation is a consequence of Einstein's theory of relativity. It's the difference in the elapsed time measured by two observers due to a relative velocity between them or to a difference in gravitational potential. Let's break this down with a simple analogy. Imagine you and a friend are each holding a clock. Your friend hops onto a spaceship and zooms close to the speed of light while you stay on Earth. From your perspective on Earth, your friend's clock seems to tick slower than yours. However, from your friend's perspective, their clock is ticking normally. But when your friend returns from their space journey, less time has passed for them than for you. This is time dilation. General relativity, the other part of Einstein's theory, explains gravity as the bending of space-time by mass and energy. This means that a clock closer to a massive object will tick slower compared to a clock that's further away. This is gravitational time dilation. Why does this happen? It's because the speed of light is constant. No matter how fast you travel or where you are in the universe, light always travels at the same speed. This constancy results in the dilating of time. So, time dilation is not just a figment of our imagination, it's a real scientifically proven phenomenon, and who knows, maybe one day we'll be able to use it to our advantage.